Hello, this is Chad Perry, and this is my video for check-in number 2. So since the last check-in, I've spent a lot of time studying this week. I think I've spent well over 10 hours studying for this class. Seems like this is a pretty long chapter with a lot of different concepts to learn, but so far I've watched all of the videos that you've created for us for chapter 11 and gone through the examples in those. So since the last check-in, I've gone from the videos on graphical analysis, where we were talking about the graphs of position, velocity, and acceleration, and how we can compare those three graphs and create them using the area under the curve or the integral, and then going the other way using the derivative, and how we can pull information from those when there's like multiple steps to a problem. A lot of the videos also talked about the three different coordinate systems that we have that we can use while solving circulinear motion problems. So those dealt with like the Cartesian coordinate system, which is what I was most familiar with, and then it moved into like the normal tangent coordinate system, where the components actually move with our graph. And then finally, it talked about the polar coordinates or cylindrical coordinates. And each of those had example videos that I worked through that worked out pretty well with the homework, because I was able to watch some of those videos and then work on a couple homework problems. So at this point, I've finished most of homework assignment number 1. I just have 2 problems left to do. And the homework problems, the beginning ones work more with rectilinear motion. So the first problem was just taking the derivative to find velocity and acceleration equations. And then we worked with rectilinear motion equations where it was all in a straight line. Like we worked on a problem that had to do with a bullet and a ball dropped off a boat and a runner, and things like that, where the motion is just in a straight line. And working in those problems, some of them we were able to use our constant acceleration equations, and in other problems we had to use the relationships we know to integrate and solve the problems. And then after that, we had some problems that had to do with constrained pulley systems, where you'd pull on the pulley and we'd have to create a relationship between the movement of a weight versus like a person pulling on an exercise machine. And then there were a couple problems that had to deal with the circulinear motion, where we had to use those coordinate systems to solve the problem. And then there were also some problems that dealt with projectile motion, where once the ball or the bullet leaves, then the acceleration is only down. There's no acceleration in the x direction. And on those we can use our constant acceleration equations as well. As far as other efforts from this week, I've looked at the textbook quite a bit and a lot of the review material. I've also spent a lot of time doing practice problems, and I've really tried to try the problems myself before watching your example videos or looking at solutions, so I can work through the problem and see where I get stuck before watching your videos. So far it was a pretty interesting chapter. There's a lot of information, and I can see how it relates to what I've learned in previous physics classes. But a lot of it was really new as well. I still need to spend quite a bit of time reviewing the material and going over things, especially the circulinear problems where the motion was not in a straight line. I'm having a hard time figuring out which equation to use, but I think it's coming, so I just need to spend a little bit more time studying, but I should be in good shape to get ready for the upcoming quiz on Thursday. So I guess that's it for check-in number 2. So far I think everything's going well. able to find all the material on the course website that I need to be successful in the course. So thank you. That's all.